Okay, in this video we will continue on the beginner's guide to SDL2 in 4th. We are using the G4th version of this for this project. So if you're just starting out with this video, you're going to want to go to github.com, Programming Rainbow, Beginner's Guide to SDL2 in G4th. You'll want to clone that repository. And again, since this is the second video, if you go ahead and go into the video 1 folder and grab the source there, main.fs, and you can copy it into the top level directory, you will be where we ended off with in the last video. So you'll be caught up to where we are currently. And I wanted to discuss that I am using G4 0.7.3. I know there is 0.79, but I was not able to get that up and running on my system. And it sort of worked, but it didn't work with these bindings. And I don't think it's the bindings fault. I think it actually didn't compile all the way correctly. But I am not able to verify that. So again, I am using G4 0.7.3 with these bindings, and I am on a 64-bit system. So just keep that in mind. Let's look at where we left off with in the last video. We did a whole bunch of boilerplate, but we got up and running. So we have this window that we can now open that is 800 by 600. It stays open for 5 seconds and it closes. It does have a title. If we look at it again, up here it says open window, and that would be up here if you had a floating window manager. Okay, and so in this video, like I said in the last video, if you try to close this, if you press the X or the red dot or the keyboard combination to close this window, it's not going to close. It's going to actually just close after 5 seconds. And your operating system may tell you that this program is not responding because it's not responding to your close request. So this video we will be implementing that. Those are events, and we're gonna start checking events and looking specifically for a close event. So when it does receive a close event, it can shut down. And we'll switch from a 5-second to an infinite game loop that will be running at close to 60 times a second. Okay, so we are going to be talking about events. So the function or the word that we will be using is SDL pull event. Now, what SDL pull event does is there's a queue of events so imagine you're in a game loop, and let's say the game loop is happening really slow, so we can just think about it for a second. So we are drawing our game, we are presenting our game, and that game loop is finished. Now you might actually move the mouse key, you might press a key, you might press a space key or the escape key, and then the game loop starts again. So we're going really slowly. So it goes back up to the top again. And if we were to pull the event queue, we would have all those events that happened since the last time through our loop that we checked the events. We're going to have a queue of events waiting for us. So imagine there's this line of events waiting for us. Now, each one of these events is a union. So each one is like this box that we can call a union. And inside of this union, there can be many different members. But it's not like a struct. A struct, if you had many different members in a struct, the size of the struct is the size of all the members together added up. So in a union, instead of you having the space for every single member that you want. Think of it like drawers, like if you had a dresser for your clothes or something, you have a sock drawer, shirt drawer, underwear drawer, all these drawers, your wardrobe contains all of those drawers together. But that's not what a union is. That's a struct. A union is if you were to have all these drawers, but you could only ever have one of them at a time. So the size of your union is going to be the size of the largest thing that you need to hold. So this is what the events are. The events is going to be a box, a container in memory that's holding something, and it has actually many different members, but it only holds one of those members at a time. So if the largest member that you are storing is, say, 64 bytes, then your union is going to be 64 bytes. Even if one of your other members is only 8 bytes, your union will still be 64 bytes because it needs to be big enough for the biggest thing that you're going to put in it. Like if you had a garage, your garage needs to be big enough for the largest car you have, or you can't put it in the garage. So imagine you have this container. It has many different members associated with it, but it'll only ever hold one of those members at a time. And the problem is you need to know what member is in it so that you can kind of get more information about it. So yeah, so let's look at these events. So these events are a union. So imagine there's a queue of events that happened, and now to look at each one of them, it's going to be a union. And these are all the members that can be part of this union. Okay, I'm explaining more than you need to know here, but just bear with me for a minute. But so each one of these are going to be defined, and they did change. They updated the SDL2 information page, so it does look different than it did before. So it's a little bit confusing for me to look at right now. Here we go. These are the unions right here. So if I open up, say, the quit one, it has it's a struct. Okay, so imagine our union, our event union, can hold the quit struct. That's one of its members. So this quit struct has the very first item is a type. Now another struct that could be inside of this union is a keyboard event. Okay, and it also, the very first member is also a type. And that's very important because for us to deal with what's inside this union, the very first thing we need to know is what type of struct is being held inside this union right now. So the very first thing we're always going to check is the type. No matter what struct is inside of a union, the very first member is always a type. So we know we can get the type of this struct immediately, and then we can process the union or the struct that's inside the union the way that we need to. So the very first thing we're always going to be looking for is the type, and for this could be an SDL key down or a key up for the type, and for a quit it's going to be an SDL quit. However, because of our naming collision, because we actually have a word called SDL quit, this is actually an enum. So this one is going to be SDL quit _enum. And I explained that here. That's because fourth is not case sensitive. So then we have a naming collision between the SDL quit function and the SDL quit enum. So I have actually called this _enum. Okay, so it's a lot of information. So basically each one of these events is a union. We need to know which struct is inside of this union, and then we can further process it. So if we know it's a quit event, we don't need to further process it. But if it's a keyboard event, we do want to find out what key has been pressed. So we'll talk about that in a second. So let's just go with the first one with the whole quit event. Where is it? Right here. This is one of them that could be there. And it has the type member, and the type member would be SDL quit. So let's deal with that first. A little bit confusing. I'm talking about C-style unions, but we're going to be representing these in fourth, and they're just going to be memory and with an address offset for us to get the information out of it. And so one thing we need to do is actually make a game loop. So right here, what we're doing is we're clearing the render, we're presenting the render, and then we're pausing for 5 seconds, and then we're shutting the game down. So there's no loop happening here. So what I'm going to do is I'm going to make an infinite loop, a loop that just loops no matter what. And it's not even going to check to see if it ever breaks out. It's just going to loop infinitely. So to do that in fourth, I'm just going to say begin. And I'm just going to tab these in. Okay. And the way that I'm going to make this loop infinitely is I'm going to say, I'm going to make it loop until false. Or loop until, I'm going to use loop until, which until will be a true thing. But what I'm going to do is I'm going to put false on the stack, so it's always going to loop. So I put false on the stack, and then put until. And basically, if this sees false, it goes back to the beginning. So there should be a sentinel here that could sometimes be true if you were trying to break out of this, but I don't ever want to break out of this. So this is always going to happen. This until always sees false, and it just keeps looping. It's looping until it sees true, but it never sees true because false is always on the stack first. Okay. Now the next problem we have is we're looping, but our loop is going to be a 5-second loop, as in it's going to sit there for 5 seconds and then it's going to loop again. So it's going to pause for 5 seconds, and then it's going to begin again. It's going to come down here, pause for 5 seconds, and that's going to be a very slow game loop. We want it to be closer to 60 times a second. So if we think of a second is 1,000 milliseconds, and we want it to happen 60 times a second, if we take 1,000 and divide it by 60, we are going to get 16 and 2/3. We'll get 16.666 forever. But SDL delay only takes in an integer. It does not take in a floating point number, and it's going to be close enough for us to just use 16. And the 0.6 seconds might actually be taken up by whatever logic we have going on in the loop anyway, so it's not really important. This is going to get us close enough to 60 times a second. It's not going to be perfect, but it'll be close. So I'm going to put 16 here, and so now this loop is going to be running repeatedly forever, and it's never going to close down. This will actually never even be seen. So I'm going to remove this. Okay, but I don't want to run this right now because we can't actually close it, because it's just going to run forever. So this is where the events come in. We want to look for the quit event. So what I'm going to do is I'm going to make another loop. Remember I said there's a queue of events. So I want to make a loop that goes through the whole queue of events and checks every event that happened. Every time it checks event, it pops it off the queue. And then when that is done, then it clears the renderer, presents. So imagine we're checking events here. Right, check events. And then we clear the renderer, present the renderer, and delay. Okay? So whatever events were here all get checked and popped off, and there's nothing left here. So as it's going down through here, more events may happen. So when we come back up here, whatever events happened since the last time we finished our whole check, all the stuff that happened here, any keyboard presses or mouse movements or quit events that were requested, will be back on the queue again for the next time it comes through here. So what we want to do is we want to run through a loop and check all of these. And this is where our word comes in, our pull event. So pull event does a couple things. It's going to populate an event. So we're going to allocate space for this event in forth, and then we're going to pass in the address to it, and it's going to get populated. But the other thing, it returns a 1 if there is another pending event, or a 0 if there's not. And we can use this to continue our loop. Okay? So what I'm going to do here is I'm going to say, now we're making another loop, so I'm going to say begin. And I want event. Now I haven't made this yet. Sorry, I skipped a step. We need to go up here. And I want to allocate an event. I need to allocate, space for one event that we can keep putting in whatever that union was each time through. So what I'm going to do is here, so I'm going to create event, and we need to allocate space for this. So the space that we need to allocate is the size of an SDL event. So SDL event, and that's going to put the size of the event on the stack, and will allocate it. So now we have the memory allocated for this event. This event will actually be the address, the way that forth works. When we put event on the stack, it'll actually just be the address, which is fine because we want the address. So now here, when we go begin, we put event on the stack, and then we call the SDL pull event. There it is. And what's this going to do? This wants the address of that event to fill it up with whatever the current union is that is happening. And then it will say while. Okay? Because what this is going to do is this is going to take this address, it's going to populate it with whatever that event was, but then it's going to leave on the stack whether it's a 1 or a 0. If it's a 0, we can finish this loop because that means there's no event. But if it's a 1, there's still an event. So we want to continue. So now we want to check this. And the way that we can check it is we want to first check the event type. So we have the event back on the stack. There's the address. And we can see if we had this event here, and we wanted to check the member if this event was in fact the address, we would do this type. Okay, we would do this. But in fourth, the equivalent to this, getting the dereferencing event and getting the type member, in fourth, we would put the address on the stack, and then we do SDL event. Sorry, this should be underscore. Event, and then tac type. And what this does is this will offset the address to where the type is. Okay, which is exactly in C what this is doing. This is the equivalent thing. In C, this is the address of the event, and this is the offset to the type. So in fourth, we put on the address of the event, and then we offset. And now we need to pull out of that address that we've offsetted to, where the type should be. We need to pull out. And what are we pulling out of this? Well, this is, God, is it not here? Hold on. Okay, yeah, here it is. It's a 32-bit unsigned. Okay, so that's what we're pulling out. So we need to make sure that what we're fetching is 32 bits, and it's also an unsigned fetch. So that will be an L at symbol, like that. That's a 32-bit fetch, and that's the unsigned one. Okay, so now basically we have whatever this event type is, and that's on the stack. So since I want to check it, I will just, I'm going to do SDL, and this is the quit. We're checking a quit event, remember? But because of the naming collision right here, this right here will be seen exactly. Now that this is a word, SDL quit is a word or a C function that is shutting down SDL. But this here is not that word. This is meant to be the enum for the event type. So because of the naming collision, we need to use enum. Okay, so in C, that would be SDL quit, all capitalization, but because of the collision, we need to use this enum. That's how I modified it. And we're running an if on that. So basically, we have this value on the stack. Now we put the SDL quit enum value on the stack, and we're comparing them. If it is a quit value, then this if will be triggered. And what will we do? We will clean the game up. We'll do game cleanup, and then we can just finish that if statement with a then. Okay, and we also need to finish the loop here, this begin loop, with a repeat. Begin while repeat. Okay, and the reason why I didn't do it down here with begin while repeat, because it would be 3 things instead of 2. You can do it if you want, you know. I would still need the while repeat down here with a value as well. So I just put the value and used until instead of while repeat. It's just another way to do it. Okay, so basically we are checking all of our events, and if any of them show up as an SDL quit type event, or we're just checking the type on every event that's in the queue, and we're popping it off until we're all done with the events. And if any of them are a quit, we're going to run our game cleanup, which is going to shut down our game and exit G4. Where is it? Right here. It's going to run through these, ding, 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 and then shut down SDL, and then we're going to have the exit value and buy. And that will be the only way that we're getting out of this loop now. Okay, so let's try that. Let me just check. I put a space here just for readability. Yeah, so we should be running roughly 60 times a second, and we should be able to quit when I ask it to quit. I didn't put close window there yet. So right now I'm going to ask it to quit. Now I don't have an X here like Windows, and I don't have a red thing here. So I actually use a key combination because I'm in a tiling window manager. So I'm going to do my key combination right now. And that worked. Okay. So that's just because I'm using Xmonad, which is a tiling window manager, but it'll be the same. You would have the X, kind of like this X right here, but this is not actually for this window. Okay, so the other thing I want to do is I actually want to check if a key keyboard event happen because I kind of want it to close if I press escape too. So that's a little bit more complicated. So since I want to check this again, and I already consumed this value here with this one, I'm going to dupe it. So I still have the value on the stack, so I can do another check afterwards. And this one, I'm going to check if it was a key down event. So do you remember here? Let's see, there's the quit event, and we have the keyboard event. So we first want to see if it's a keyboard event. And there's two types of keyboard events. There's an SDL key down event and an SDL key up. And this is on the type again. So we're already checking the type. It's on the stack, so we can check it against this value right here. So we'll do SDL key down, like it's spelled, and the same. Okay, but now we actually want to know which key was pressed. So what I'm going to do is I'm just going to put it in line here. It doesn't matter in forth if things are in line or down below. I just do this for readability. You can keep things going out, or you can make them. It doesn't matter really. It's just going on the stack or coming off. So I just do this for readability. Right here, what I'm going to do is I'm going to put the event address on the stack again. But this time I'm getting a different offset. I'm not trying to get the offset of the type. I'm trying to get the offset of the keyboard event key sim. So if we look in here, we've already checked that the type is keyboard key down. Okay, but there's something else here. There's another member besides type, which is the key sim. So if I open this up, which is already over here, we have a member of this one is a scan code. Okay. And these scan codes are here. They changed this page. It looks different, but it doesn't matter. These scan codes, like SDL underscore scan code I, would be the I key, underscore escape would be the escape underscore return. You kind of get the idea. It's pretty obvious what's happening here. So what I need to do is I need to check. I need to get the address of the event and offset it to the key sim this time, and I'm going to check it up against a scan code. So I'm just going to do it in line here. I could put it on the next line down. It doesn't matter. However you want to do it. It's stack based. It's just going on the stack or coming off the stack. So it doesn't matter which line it's on. Okay, so I'm going to put event back on the stack, and I'm going to do SDL keyboard. Now this is just again changing the address offset. So the offset, there was an offset for event type, and for this event, it just moves the address over, and it's actually probably the same address because it's the first member. This is moving the address over to a different spot where it should be holding the keyboard key sim. Okay, so that is keyboard key sim. So what I'm going to do here is with this offset, key sim offset, I'm going to do the L. And this might not be 100% correct, but I don't think there's any negative numbers. This would only be a problem if there's any negative numbers. So we want to check this value that we just grabbed here against the escape key. So that's going to be SDL scan code escape. We're going to put that on the stack, and then we're going to check the evaluation and then run the if. Oops. And this will do the same thing. We'll say game cleanup, and then we'll close down that if. And sorry, it's then. And we also need to close up this if right here. So there's going to be another then. Because this right here is an if statement. And when we get inside this if statement, so we could have done it like this. This is an if statement here, and there's the then. And this is an if statement here, and there's the then. Okay? So the first one is checking the type, if it's an SDL key down, and then right away we throw the event back on the stack and offset it to capture the actual scan code, and then we are checking that against the escape to see if it was the escape, the scan code. Okay, so this should give us, oh, it looks like I have a then already on the stack here. So this should give us the ability to press escape or to tell it to close. Okay, so I'm going to press escape and it closed. I'm going to check it again just to see if I can close it the normal way. So I'm going to tell it to close the normal way with my key combination. And that closed as well. We did forget to change the title up top, so I'll do that here. This should be close window right here. Close window. Okay, closing it with escape and then closing it with the key combination. Okay, so let's go through what we've done here. We have allocated space right here for an event. Like I said, it is a union that has a whole bunch of members, and each of those members are structs. But the very first member of each of those structs is the type member. So you can, no matter what's in there, you can always check the type first so that you can further process it. Because if I tried to get which key was pressed from a quit event, that would not work because the quit event doesn't have a key, a keyboard scan code associated with it. So we've allocated the space for the event right there. And then down here, we have created this loop by using begin and false until. And that's going to be just an infinite loop that never ends. And we changed our 5000 to 16 to approximate a 60 frames per second loop. Like I said, it's not perfectly 60, but it's close enough. It's fine for this. And then in here, we're running another loop. And this loop right here is going to go through all the events. It's pulling the events. It's taking one event at a time over and over again until it runs out of events. And it's going to check the event if the type is of an SDL quit enum or an SDL key down. Either one of those events are going to trigger. The quit one just shuts it down. The scan code one then puts the address back on and gets the actual key that was pressed. Which key actually triggered this key down event is what we want to know. And that we're checking that against escape. So if you press any other key, it won't shut down. Let's just check that real quick just to make sure, because I have made this mistake in the past. I'll press space bar, J, B, G, 1, escape. Okay, so it is working just on the escape key. So that is doing that, and we're still doing the same render clean, render present. This delay is shorter now, but this is a proper game loop now. So we have event checks and we have drawing the screen and delaying. In the middle between these two is where we'll update the game state later on. Okay, so yeah, I did talk about the fact that I'm using 0.73 of G-Forth, and I am on a 64-bit system. So again, these bindings, I kind of made these, so I hope they work, but if they don't, you can ask questions on the GitHub repository or under the YouTube video not the live version, but the actual video on demand version, the normal video. I think that's going to be it for this video. I hope that was entertaining or educational. I hope you enjoyed this, and thanks for watching. Bye.